In this video, we look at the shape of parabolas. The parabolas you see here all look quite different in shape. For instance, the parabola P1 is much flatter than the pointed parabola P2. In this video, we will see that all parabolas nevertheless have the same shape. They all are similar. Starting point is to define a parabola on the basis of a point and a straight line. The point is called the focus, and the line is the directrix. The focus and the directrix determine a parabola. P is on the parabola if the distance from P to the focus F equals the distance from P to the directrix R, or dPF equals dPR. All points satisfying this condition form the parabola. Thus, every point line pair determines a parabola par FR. Here you see 2 point line pairs with the same focus F and with directrix S parallel to directrix R. The perpendicular from F onto the lines intersects the line R in the point V and the line S in the point W. The distance from F to the line R is therefore equal to the distance from F to the point V, and the distance from F to S equals the distance from F to W. The ratio of these distances is denoted by K. Thus K equals Fw over Fv. And therefore we have Fw equals K times Fv. Let now R be some point on the line R. The line through F and R intersects the line S in the point S. Because the lines R and S are parallel, the triangles FVR and FWS are similar, and therefore we have Fs equals KFR as well. So, if you scale with vector k from the focus F as center, the point F of course stays fixed, V is transformed to W, and R is transformed to S. Thus, the line R is transformed to the line S. This means that the point line pairs FR and FS are similar. Here again, the 2 point line pairs are shown with coinciding focus and parallel directrices. Both determine a parabola. The black one, par FR, and the red one, par FS. The point P is on the black parabola. Scaling from center F with vector k transforms P to Q. We will show, as the figure already suggests, that Q lies on the red parabola. There we go. Since Q is the image of P, the distance from Q to F equals K times the distance from P to F. The scaling transforms the point R into the point S, as we have seen before. So the line segment PR is transformed to QS. And since scaling scales all lengths with the same vector k, we have QS equals PR. Finally, since P is on the black parabola, the distance from P to F equals the distance from P to R. So these are equal, and thus these are equal as well. So the distance from Q to F equals the distance from Q to S. Finally, the segments QS and PR are parallel, and thus QS is perpendicular to the line S. And so the distance from Q to the focus F equals the distance from Q to the line S as well. Hence, Q is on the red parabola. Of course, this holds for any point on the black parabola. Thus, scaling with vector k and the focus F as center transforms par FR into par FS. So, par FR is similar to par fs. Still, they don't look very similar. Taking another perspective, things become clear. The points P and Q are on the black parabola. Scaling from f with vector k transforms P to the point P' on the red parabola and Q to Q', also on the red parabola. Also, some arbitrary point T between P and Q is transformed to the point T' between P' and Q'. Thus, the parabolic arc PTQ on the black parabola is scaled to the arc P', T', Q' on the red parabola. Hence, the parabolic arcs PTQ and P', T', Q' are similar. Thus, two parabolas with the same focus and parallel directrices are similar. Now we show that indeed two arbitrary and hence all parabolas are similar. Here are two parabolas, a black one with focus F and directrix R, and a red one with focus G and directrix S. We translate the black one so that the focus coincides with the focus of the red one. Then we rotate the new black one until the directrix is parallel to the directrix of the red one. Of course, the translated and rotated black parabola is similar to the original black one. Translating and rotating just changed the position and orientation. Now the situation is precisely as earlier in this video. We just have to scale with the appropriate vector k, that is the ratio between the distances from the foci to the directrices, and we get the red parabola. The black and red parabola are similar, hence all parabolas are similar.